And is it focused? Okay. So this is math.
Now you switching this class?
Yes. No, I told some people if they wanted to come to class today, we're going to be doing coding. And for people who just want to have experience with coding. So this is Math 331, Lecture 3. And what I want to do today is I want to talk a little bit about how you would code and how you would attack problems. I am going to be doing things in Mathematica because I was a double geek. I was a math physics major, which forced me to really learn how to use Mathematica when I was in college. So this is my go-to language. It's a very friendly language once you learn the syntax. It has a lot of functions that are predefined. It has really good graphic interfaces. So for all of those reasons, it's great. If you want to do serious computations and you have your very large matrices to work with, this is not the best way to go. But for a lot of what we're doing, this is fine. So what I want to do is talk about two problems in particular, just give you an idea of how you would set up some for statements and whatnot, how you would attack stuff like this, and then some tricks you can do to code more efficiently. Sometimes there is no need to do things efficiently. When I was a senior, I was doing a physics thesis, but I needed to deal with primes. And I needed to create a data file of primes. But I only had to create it once. So my code didn't have to be exceptionally efficient because it was a one-time cost. If you're using things again and again and again, then you really want to look at how you would do these things. So what I want to do first is the problem. You've got numbers 1 through 9. Each number is used once and only once. And you want to get 3 fractions that add up to 1. Okay? And then when we're doing this, I want the fractions to all have numerators with 1 digit and denominators 2 digits. There are a lot of symmetries you can do. In the 3 fractions, without loss of generality, I could say either the number 1 or the number 9 is in the first fraction. Why? Why can I assume the first fraction has either a 1 or a 9? So I'm going to have things of the form a over bc plus d over ef plus g over hi. Why can I assume that either a, b, or c is 1? Yeah, each number occurs once and only once. So if the 1 is in this fraction, we'll just reorder that and have that first. So I could actually make things a little bit simpler and say, in A, B, or C, one of them must be a 1. And that would save me a little bit of time when I'm coding. And then the rest, I could maybe break it up into 3 cases. Case 1, A is 1. Case 2, B is 1. Case 3, C is 1. Okay? So if I did that, that would save me some time, but then I would have to spend more time coding. And so right now what I want to do is I want to do as little time coding as possible, because I only have to run this once. How many of you know how to program? Okay, so I will then go through this and just give you just some general statements about how to do stuff like this. I often find it's useful to open another notebook, just because that way you can have something to test things on. And so I will open up something over here. So I'm going to say list equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Because those are the 9 numbers I'm moving. I could also do list is the empty string, and then for I equals 1, I less than equal to 9, I plus plus, list equals, bless you, append to list I. All right. Which is a better way to create the list of numbers 1 through 9? The first line or the next two?
The next two.
Why?
If you want to get 1 through a million.
Okay, so if you want to get 1 through a million, I agree that the second way is better. If you want to just get 1 through 9, which way is better?
The first.
The first, right? So this is the way that's going to generalize. But if I only care about the numbers 1 through 9, it's such a small thing, just do it like this. Now later today we will work with a deck of cards. And then for a deck of cards, how many cards are there?
52.
52. Is the accent hard or?
What?
Okay, no, I was wondering if people were having trouble with the word cards.
Oh no, we just
Okay.
actually had a programming assignment where we had to make a deck of cards minus the jokers, so 50 cards instead.
No,
Oh, sorry,
it's 50. It's
54
54 cards.
54 with the jokers.
Correct.
Yes, right.
And that's actually one of my names, the Joker. Okay. Anybody know why?
You make a lot of jokes.
No.
I don't know.
Nobody knows?
Your Batman version.
No. Oh, extra credit. Why some people call me the Joker. All right.
Like people at the school.
I will not say more. I will leave that as cultural extra credit to figure out why I am sometimes called the Joker. All right. So we now have our numbers 1 through 9. What I want to do is I want to look at all the permutations. So Mathematica has a beautiful command called question mark, and you put that in front of something, and it will explain what that command is. So question mark permutations talks about the command permutations. So permutations list generates a list of all possible permutations of the elements in list. Oh, that looks pretty good. So let's let, you always want to have good descriptive names. So let's let perm list equal permutations of list. And now when you put a semicolon, it suppresses the output. If I didn't put that there, it would actually print the entire set of permutations. How large is that? It's 9 factorial. So it would print 362,880 elements. Okay? As a check, let's look at what is the length of perm list. And so its length is 362,880. Great. I can pull out an element. I could look at perm list 1, so I need double brackets around it, and that gives the first permutation 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the space balls. And then I can do the last one, 9, 8, 7, 6, 5, 4, 3, 2, 1. I can put in a more general one, 1, 2, 8, 3, 7, 5, 4, 9, 6. If I wanted the third element of that, I would just do the 3,680 element in my list, and then take the third element of that. So what should that be? It should be 8, and I do get 8. So this is a way now to get my permutations. And now what I can do is for each permutation, once I have that, the first element will become my A, the second element will become my B, my third element will become my C, and I'll just check and see if it works. So I will take the work that I've done over here, I will take the good code, and I don't need that part. I don't need that part. I just need these lines. And I'll transfer back. I'm not going to create a function here because I'm only running it once. Normally I would create a function and then I would have maybe some input parameter, but there's no need to do that because I'm only doing this once. So list is empty. I append 1 through 9. Perm list is my permutations. And now what I will do is the following. For n equals 1, n less than or equal to length of perm list. I could put in 9 factorial, but this is just a little bit safer. N plus plus, and then this begins my for loop, and then this brace ends my for loop. And then the bracket here closes the for loop. So this is a begin and an end. And then I'm going to put comments and says end of the n for loop. Most people do not put comments in their code. This is not a good idea. How many of you have used LaTeX? So if you use LaTeX and you need to create a graph or something simple, I highly suggest you put the code in your LaTeX file and just comment it out. And then that way, if you have to change something, the code is very easy to find. All right, so now what I want to do is I want to take one of my elements, so I'll call temp will be perm list of n. And now I'm going to form my three fractions. So x will equal perm list, will be temp 1 divided by 10 temp 2 plus temp 3, right? Plus, well, let's do this efficiently. I'm going to add a plus I here, a plus I here, and a plus I here. And now what I'm going to do is I'm going to say this will be, I will sum this. What should be my range for I? I goes from what to what? 0 to 2. And so this is just a faster way of writing it. So when I equals 0, I get the first element divided by 10 times the second plus the third. When I equals 1, I'll get, oh, wait a minute, I think I need to have 3 times I. Yes, 3 times I believe. And now when I equals 1, I would then get the fourth element over the fifth times the sixth. And then when I equals 2, I would get the seventh over the eighth times the ninth.
Is that how you do star 3 times?
Oh, sorry, I put the star in the wrong spot. 3 times. You actually don't even need to put the star in Mathematica. It interprets this as 3 times I. Again, I think it's better to be a little bit pedantic and put in extra stuff, make the code a little bit easier. I should really put some comments here as to what's going on. And now what I'll do is the following. If x double equals 1, then I want to print 10. And so I'll run the code. And so it gave 6 answers. How long did it take to run? I could put a timing command so that it would explicitly tell me how many seconds it took to run. 1 Mississippi, 2 Mississippi, 3 Mississippi. So it's on the order of 3 or 4 seconds as a rough estimate. This is why it was not worth taking any time to make this program efficient. The runtime of this program is so small, it would be absurd to try to optimize it, unless you're learning good things by doing that. Or unless you're then going to extend this later. We're not. Are you surprised that there were 6 answers? Yeah, they're the same ones. Do the number of answers have to be multiple of 6? You always want to get a sense of how things are. Why should the number of answers be multiple of 6? Yeah, how many ways do we have to order the 3 fractions? We have 3 ways of choosing which one is first, then 2 ways of choosing which one is second, and then 1 way of choosing which is third. So there have to be 6 answers. So this is the very simple code to do something like this. Okay. Any questions about this problem? One thing you should do when you are coding is you should frequently save your program. I probably should have saved it earlier than I've just done right now. System crashes happen. If you want to be really paranoid, what should you do if your code is extremely important to you? Back it up. So you actually have 2 file names. So I would have intro coding 2018 and intro coding 2018 backup. And you just alternate between the 2. Because that way, what happens if there is a system crash or a power outage while you are in the midst of saving your file? You can lose everything. I know people who've had this happen. I know people who have things that they work on only on the cloud, and all of a sudden something goes wrong and they have no hard copy of their file on their machine. So I strongly urge you, always back things up, always have an accessible copy, always have good descriptive file names. For some of you, I have passed on resumes to Williams alums. If you send me something called resume.pdf or cv.pdf, I will not pass it along, because the people I send it to would have to download it, change the name, upload it again before they can send it on to their boss. And I've had people tell me it's not worth it. And that has literally eliminated certain people from consideration. You want to make it as easy as possible. You want to make it as clear as possible what's going on. All right. Any questions on this one? All right. Let's go to a more interesting one. This is a probability problem. I want to consider hands of 5 cards. I want all cards to be equally likely. And I want my hand to have at least 2 kings and at least 2 queens. So what do I need to check? What hands would work? What hands would satisfy this? So we'll go over here now. So what possible hands would work?
Do you mean like all the numbers, or just like name like one?
The structure of the hands that would work. I want at least 2 kings and at least 2 queens in 5 cards.
Well, you'll have to 4 cards already decided, and then just any other card additional that will work.
Okay. But you've got to be careful. So one possibility is to say, I start off with 2 kings, and I start off with 2 queens, and then I choose my 5th card randomly. But you've got to be very careful that you're not double counting. Because what if you choose a king or a queen?
Mhm.
So what are the different structures of hands I need to look at?
Could I see the problem statement?
Sure. So I want to have at least 2 kings and at least 2 queens in 5 cards. So what is the structure of the hand going to look like?
And you can pick just however many times.
However many times. So give me a hand that works. 2 kings, 2 queens,
and a number card.
Right, so let's denote that as, say, king, king, queen, queen, O for other. I'm not quite sure why I changed the size, so let's increase the size. So that's one possibility, something of the form king, king, queen, queen, other. Or if you want, we can do N for not a king, not a queen. What else could work? Yes?
Sorry.
Question?
Yeah, I'm kind of confused. Like, order doesn't really matter here.
Correct.
So, like, I mean, there's only like 2 structures.
Well, what's the other structure?
I mean, it's either just Jack then,
I'm sorry?
No.
or
That's
Jack is
included in
included
N.
in that, I think.
Jack,
oh, it is.
Because N isn't a number, it's not a king or not a queen.
right.
Oh, I see. Sorry,
Or-
I thought that was he said for N for number. That's why I was kind of.
Oh no. And is not like the, and it's just is not a king, not a queen.
Okay, I see. Thank you. That
So
makes
I'll
much
write
more
it as
sense.
not. So I'll space it out. King, king, queen, queen, not.
Okay.
So what else? What other structure could we have?
King, queen.
Yeah, we could have king, 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 queen, queen, and then we could also have
The opposite.
king, king, queen, queen, queen. So we have to look at all of those. So we could calculate this with probability. Right? We could actually just calculate what is the probability of each one of these 3. It's not too bad. You know, if I want to choose 3 kings, how many ways are there to choose 3 kings? 4 choose 3. How many ways are there to choose 2 queens? 4 choose 2. How many ways are there to choose 5 cards? 52 choose 5. So I can calculate the probability of each one of these and add them, and they're disjoint. We will assume we have no knowledge of binomial coefficients and probability. And so we want to write a computer program to simulate this. Right? We want to build intuition. So how would we build intuition? We have to somehow create a deck. Right? All right. So everybody comfortable? I can delete these? We need to create a deck. How do you want to create your deck of cards? Yes?
I was just going to do 1 through 52, and then the first few are kings.
So one possibility is to create a deck going from 1 to 52. So deck is initially defined to be empty, and then for n equals 1, and let's do C for card. For C equals 1, C less than equal to 50. Well, come on, 52. C plus plus. No, we're not using C++. Deck equals append to, so we're appending to the list the card C. We're appending to deck the card C. And then if we print out deck, we see deck is the numbers 1 to 52. All right. And so if we do this, then you want to say the kings are 1, 2, 3, 4, the queens are 5, 6, 7, 8.
You can just like replace the first 4 with 1, and then the second 4 with 2, so then you don't have to say or check.
So you're getting better now. So instead of doing 1 to 52, what we could do is the following. For C equals 1, C less than equal to 4, come on. 4, C plus plus, deck equals append to deck 1. So that will make the first 4 cards equal to 1. And now we'll do C goes for, we could do 1 again, but let's do 5 to 8. Now we'll make the deck 2. And now we go from 9 to 52. Okay, so now what do you want to do?
Swap the C with 3, maybe.
I'm sorry?
For the sort of last for statement, because we don't care what the cards are that aren't kings or queens.
Okay.
So have the other category be 3 instead of
Or 0.
Or 0.
I like 0. You'll see in a moment why 0 is beautiful. All right, so now how would you tell if you have at least 2 kings and at least 2 queens? What do you mean by sum?
Like, you just sum the value of the cards and then see if it reaches the same.
Uh-huh.
Make king 1 and queen 10.
Yes, that's the trick. So now if you sum, the ones digit is the number of kings. The tens digit is the number of queens. I don't care about more advanced theory about the deck of cards, right? I'm only concerned for this particular problem of, do I have at least 2 kings and at least 2 queens? If I was going to write a program to analyze more general problems in probability, this would not be good. This is tailoring it very specifically to the problem of interest. That's fine. Okay? So now all I have to do is check and see, okay. So let's go. So what we'll do is we'll take this, and now we're going to make a real program. 2 king, 2 queen. That's going to be the name of my function. And num_do will be the number of iterations. So you put an underscore in Mathematica to say that it's a variable. Then you do colon equal to define a function, and you use the word module. So the bracket begins, and then the bracket here ends. So I'm going to write end of module. You can then have local variables, and you put them in the curly braces. The local variables are only seen by the function, they're not seen by the rest of the notebook. Sometimes you want to be very careful that if I run something here, I don't want that value to be used someplace else. I want to keep things separate. So I'm not going to worry too much about that. All right, so now we first initialize deck. So we'll do some comments. Initialize deck. All right, so we've got our deck now. And now here's the main part of the program. For n equals 1, n less than equal to num_do, n++, begin, end, and this will be end of n for loop. And I'm going to just add one more thing before I go into this. I'm going to define success to initially be 0. I want to just count how many times do I see at least 2 kings and at least 2 queens. So now we have to choose 5 cards. How do we choose 5 cards? Yes?
For you to take the first 5.
So one possibility is to take a random permutation and take the first 5. So that's one way to do it. Mathematica has a whole slew of commands for something like this. Random sample. Random sample gives a pseudo-random sample of n of the EI. So I think if I do random sample deck 5, this will just give me 5 cards chosen at random. And you can see the numbers coming down here. Are these looking reasonable? Most of the time I'm getting at most 1 of the special cards. How many special cards do you expect to have? So how many special cards, how many kings or queens would you expect to have in 5 cards?
None.
Is this a random? Is this still assuming a random sample?
Assuming random
or-
sample, I'm choosing my deck, I'm shuffling.
It's got to be the probability of like how many cards you have over, or so it's like you have 8 then of the special card.
We have 8 special cards out of 52. And then each card, if you view that independent of all the others, has an 8 out of 52 chance of being special. And then we have this beautiful thing called linearity of expectation. The expected number of a sum is the sum of the expected values. So each one of them has an 8 out of 52 chance, so I would multiply that by 5, so I get 40 out of 52. 40 out of 52 is less than 1. So I expect most of the time I would have at most one special card. In fact, it's just a little bit less. And as you see here, I'm often getting 1 or none. So it's at least looking reasonable. Whenever you do coding, you always want to have some rough feeling of what should you expect, and then do some quick sample tests to see if it's reasonable. All right, so now I go here, and so now I can just do the random sample. So I will do hand equals random sample. So this chooses 5 cards from deck randomly. And I will save this because it's been a while. Now what I want to do is the value is going to be the sum of hand, let's do C. C goes from 1 to 5. And now, how do I tell if I have at least 2 kings and 2 queens? I'm sorry?
The sum must be greater than 22.
Greater
than or equal to 20.
All right, so one possibility is it could be greater than equal to 20. What might be wrong with that? Yes?
If you get 3 queens and no kings,
If I get 3 queens and no kings, it doesn't count.
but it's over 20.
Ah, good. So what you're saying is if I get 3 queens and no kings, or 3 queens and 1 king, then I would have a sum of 31. Yes?
I would say sum divided by 10 is greater than 2, and sum mod 10 is greater than 2.
Yeah, so there's a lot of ways we can do it. We can say, is the sum at least 20? And then if that's true, then we can look at the ones digit. So now let's check the mod command. I know some people have been expressing love of modular arithmetic. So if we look at mod 1512, that's 3. So what this is saying is if you take 15 and look at it modulo 12, you get a remainder 3. So this tells us that the modulus is the second number. So I would want if value is greater than or equal to 20, which means I have at least 2 queens, right? And then if mod value 10 is greater than or equal to 2, which means I have at least 2 kings, then success equals success plus 1. For those of you who know C++ and stuff like that, you could do, I believe, plus plus here. Okay, so now that finishes the getting loop, and now what I want to just do is print success rate is, and I'll do 100.0 times value divided by numdo, and I'll put a period at the end so I look fancy.
Should it be success divided by number?
I'm sorry? Oh, it should be success, thank you, yes. Okay. And so the name of my program is 2 king, 2 queen. So now let's do it 100 times. Success rate is 0. And if I put this in timing, it will tell us how long it took to run it. So the 0 means it ran so fast, it can't even tell you how long it took. It is within its accuracy of 0. Do you believe that the answer is 0? All right, I'll run the program again. Still 0. What do I need to do?
Look through the code and see what's wrong with it.
Do it more.
Is it default integer division or is it?
Well, by putting the 100.0, I actually convert everything to
Because it
reals.
does 10 times the success rate.
Yes.
100 is too few.
100 is too few. If you flip a coin once, what are your possible estimates for the probability of the coin landing on a head? If you flip a coin once.
100%.
100%
For nothing.
or nothing. So if I'm doing only 100 simulations, each run is either a success or a failure. The only outcomes I can get for my estimates for the success rate is 0, 1 over 100, 2 over 100, 3 over 100. If the success rate is 65%, say, then I would expect with 100 flips, with 100 runs, I should be getting something close to 65%. What do you think the success rate is? Close to zero. Right? Let's go back. So let's look at binomial. So we wanted 3 kings and 2 queens, right? So choose 3 kings, binomial, and choose 2 queens. And then we're going to divide everything by 52, choose 5, the number of ways of choosing. But now I could have 3 kings and 2 queens, or I could have what's similar to 3 kings and 2 queens. 2 kings and 3 queens. So I should really multiply this, I think, by 2, right? So that's all the ways to have 3, 2. Now I have to do the 2, 2. What's the way to have the 2, 2? I would have binomial. I have to choose 2 of the kings. Binomial. I choose 2 of the queens. And now how many cards are left over? 44 cards are left over, right? And I have to choose one of them. So when I do this, I get 2 over 3,185. If I put a 2.0 here, that's not going to give me a decimal. And if I multiply by 100%, I'll get the percentage is 0.06%. So running it 100 times is not enough. All right? Let's put in a couple of zeros. So this is just, I want to give you some good coding. How many of you are getting impatient right now? I'm getting impatient. But maybe it's about to finish, and we just need another 3 or 4 seconds. And if we're patient, it will. So what's really bad is I have no idea of where we are in the code. I have no idea how much has been run. Now when I break it here, I could actually print out n right now and just tell me where we are. So if I print out n is at 6 million. Okay, so we've only done about 6%. So doing it this many times is not going to work. What you want to do is you want to always put some lines in your code to give you a sense of where you are. This part here, the for n equals 1 loop, this is the real time killer. So I want to put something that's going to tell me how much we're doing. So if mod n num2 divided by 100, well, let's do divided by 10, equals 0, print have done 100.0 n divided by num2 percent. And so now when I do that, it will print out every 10%. If you want to do every 1%, I can just change this to 100. And so now, let's get rid of 2 zeros. So we'll do it 1,000,000 times. And now you can see, okay, how much progress we're making. If you have a serious program that you care about, you want to save information as you're going. So it says the success rate is 0.0669, 0.0627. That's not bad. We could easily go up another factor of 10, based on how much time it took. This took almost no time. It took 7 seconds. How long would you expect this to take now if we go up by a factor of 10? Yeah, this is a program that's going to scale very nicely. So the other thing when you're doing problem solving and you're doing coding is you want to get a sense, is it going to just be a linear growth rate as I change things, or is there going to be a huge cost? So a lot of times if you are looking at things, maybe as the number gets larger, you have to do more and more operations. Maybe for the number of size x, you have to look at x squared things. And if that's the case, then it's going to take a lot more time. So now it's at 50%. So we probably have about another 30 seconds for me to just go up here and just wave my hands before it finishes. Then in probability, you can actually do some stuff that will give you some ideas of how well can you trust the output, if you do the simulation. A simulation is not a proof in a math department. In other departments on campus, it will be accepted as a proof. And I remember I was doing a small project with a student a few years ago, and I was saddened when I realized that the thing we were trying to prove was already proven in the computer science literature. And then I saw the paper, and I saw that they had just run a lot of simulations and observed the following. So that's not a proof. That doesn't mean it always happens. All right, so now we get 0.06338, and the correct answer is 0.0627. So that's not bad. And we're seeing here, it scaled up very nicely. It was like 7.2 seconds. It's now about 72 seconds. So the question is always, when can you do things better? So I will end with one last thing that I'm not going to code, but I will just leave this as a problem for you to code. Any baseball fans here? All right. Any math fans here? All right. Well, more hands should be going up on this one. If not, more power to you for taking a 300 level math class. But who knows what an Erdős number is?
Oh, yeah.
All right. What is an Erdős number?
It's how many co-authors you are away from Erdős?
Yes. So if you wrote a paper with Paul Erdős, you have an Erdős number of 1. If you wrote a paper with a colleague who wrote a paper with Paul Erdős, you have an Erdős number of 2. So my Erdős number is 2. It used to be 3, but years ago I asked a friend of mine who is a senior professor, can I please write a paper with you to decrease my Erdős number? He said, sure. So we wrote a paper. My kids actually have Erdős numbers of 3. So we might cover that later in the semester. So if you want to get an Erdős number, if we work on a project, you can get an Erdős number. There are people who have tried to sell their Erdős numbers. And they've posted, I'll write a paper with you, and you will get an Erdős number of mine plus 1. And I know one time when this was on eBay, serious mathematicians had the highest bid with no intention to pay because they felt that this was wrong. And then there are other people who say, I will make sure you do something non-trivial so that you earn the Erdős number. Who knows what a Kevin Bacon number is? Or the 6 degrees of separation with Kevin Bacon. Have you been in a movie with Kevin Bacon? Have you been in a movie with somebody who's been in a movie with Kevin Bacon? So some people have a finite Erdős-Bacon number. The Erdős-Bacon number is the sum of your Erdős number plus your Bacon number. Natalie Portman has one of the best Erdős-Bacon numbers in the world. The person who played Winnie Cooper from The Wonder Years, she's written a lot of math books. She also has a really good Erdős-Bacon number. Most people have an infinite for at least one, if not both. Who used to have the record for most home runs? So this is for the baseball fans.
Yeah, Barry Bonds.
Barry Bonds is the current one, and there's a nice asterisk by him because of the alleged steroids. Before Bonds, Hank Aaron, and before Hank Aaron, Babe Ruth. So for years, Babe Ruth had the most home runs at 714. And to put Babe Ruth's power in perspective, there were years when he was playing, when he as an individual hit more home runs than every team in Major League Baseball but one. Why can't he have done better than that? Because he's on a team.
He can get traded.
That is the only way to do it. And in fact, I think CC Sabathia led the American League and National League in shutouts one year because he was traded mid-season. So it is technically possible to have more home runs than any team if you are traded. But back then you didn't have as many trades. So Babe Ruth for years had the record with 714 home runs. And then Hank Aaron finally broke it at 715 and went a little bit higher. And people noticed a lot of interesting properties between the numbers 714 and 715. One of the things they noticed is that the sum of the primes that divide 714 exactly equal the sum of the primes that divide 715. And so these are now called Ruth Aaron numbers. I know the person who wrote a lot of papers on this. He actually wrote some of the papers with Paul Erdős about this. And as a nice twist, Paul Erdős and Hank Aaron were actually getting honorary degrees from the same school in Georgia at the same time, and they signed a baseball. And so the question was whether or not that counts as a co-authorship with Erdős. Is signing a baseball sufficient? But 714 and 715 have the same sum of their prime divisors. Are there infinitely many numbers like this? How do you find numbers like this? Well, one thing you could do is you could write a code. I'll go back over here. So this would be like Ruth Aaron. So we'll call it RA. I don't know why it doesn't want to let me do things. And so what you could do is you could write your code, and you could have your number n and n plus 1. And you could have your function f of n, which would be sum of prime divisors. And you could compute f of n and f of n plus 1, see if equal, and then increase n. Okay, so does everybody get the code? So we would basically have a code for n equals 1 to big number in steps of 1. Begin, compute this, see if equal, then increase n, and then n. So that would be my pseudocode. Okay? This is probably the easiest, most straightforward code you can do. Does anybody see a way that you could make this much more efficient? You're going to have a 50% savings in runtime. Yes?
When you compute n, and then the next time, or when you compute n plus 1, that's n the next time.
Yes. So what we can do is we can compute. So let's say compute f1, f2, and make f lower equal f1, f upper equal f2. And now we compute fn plus 1, see if equals f upper. And then if yes, increase count by 1. And now we would make f upper would now be fn plus 1. It would be our new value. And so you only have to calculate half of them. And then you just march down. So if you think a little bit, you can often make your code a lot more efficient. We don't need to recompute both of them each time. If I've computed f5 and f6, well, now when I check f6 with f7, I just use the value of f6 I calculated before. So always think about what you want to save. The other thing is, if you're in a situation where you might have to change what you are studying later in life, you want to save more things than you might initially think you need. All right, so this is, I think, a good place to stop. I just wanted to give you, some sense of coding, some sense of how you attack problems like this. I'm going to hopefully hit